make a few notes for my children and grandchildren if they ever want to power up this encoder tester and make it run. So I'm going to document it on video, and they'll be able to continue using this. So here, let's power up the computer. It's an old computer. My daughter and son helped me put this computer together back in 96, 97, 98, thereabouts. Somewhere is in the mid to late 90s. So here we're coming up. The computer runs on Windows 98 operating system. Takes a little bit to come up. When was the last time you saw that? Oh, it's been a while, hasn't it? Here shortly we'll get closer to the screen right here. Okay. It didn't take long for that computer to come up, did it? Here's the main screen. And I'm going to turn on the encoder tester. I'm applying 120 volts AC, single phase to the power supply. You can hear the cooling fans come up. The cooling fans cool the stepper motor. It can get quite hot, especially if we run it all day long. It's okay. It's a cooling fan on it. And then there's cooling fan on the optocoupler input resistors. They get hot if I set the encoder power to 24 volts DC. So there's a cooling fan on those. They'll spin up. There's no guards on them, so be careful of your fingers. Now we'll click on this icon right here, encoder. This is the very first screen you'll see. Username and password. The username is Moke Hey Sook. Moke space Haesuk. The password is Misty33. MISTY33. Misty was our sister flight when I was stationed with the OV-10s down in South Carolina, Shaw Air Force Base. We were called the Ravens and they were called the Misty. And 33 was the age when I made this password, Misty33. Click on OK, and there we are. The next thing you want to do is go up here to port. And I don't know why I can't save this. I'm too doggone old to figure it out. But it always comes up in SPP mode for the line printer port. So we want to go to this drop down menu and select bi-directional. And that sets that line printer port, LPT1, at address 378 to bi-directional. Click OK. Now click incremental. And this is the incremental encoder test screen. Now on the encoder interface board that I made, there's a motor power board that will disconnect or route the stepper motor voltage to the stepper motor. And if the LED, there's a green LED on that board, if it is off, we need to turn it on. So go down here to motor power and click on that. And then look over there and see if the LED is on. Yes, it is on. Now we can run. There we go. There's our encoder waveforms. A, B, Z, A bar, B bar, and Z bar. Now I like to reset the counters with this radio button right here selected to yes. And when, let me do it again because that came up pretty quick. Set that to yes, and when the home pulse is found, it resets these counters to 0. Another thing I like to do is, you see how the waveform is moving gradually to the left or right? If you trigger on either channel A or channel B, it won't move, it won't shift either way. There we are. We had the home pulse and the counters have been reset. So let's go ahead and select channel A. We'll trigger on channel A. And you'll see that the A and A bar have turned green. And now the waveform tries to stay in one place. I'm going to go get a sip of my coffee while y'all look at that. Okay, let's look at a few more functions that you can perform on your encoder. Just click Stop Test, click Clear, and right here are radio buttons, yes and no, for count pulses and for missing pulses. Let's do the count pulses first. That will tell us how many pulses per revolution in between the home pulses there are on that encoder. So we click on yes, and we click OK. It says click OK to start test or cancel to exit test. We'll click OK, and now what's going to happen is when the home pulse first occurs, the counters will be reset. And when that same home pulse occurs again throughout the revolution, it will occur numerous times, but when it occurs for the second time, the stepper motor will stop. There's the first home pulse. There's the second home pulse, and we've stopped. You can look at A and A bar are 500, B and B bar are 500, and it says encoder pulse count equals 500. Let's click OK. Now we'll do the missing pulses test. This is the same as the count pulses test, but what will happen is if any of these are unequal to each other, we have missed some pulses. Like for instance, if we had a speck of dust or something on this B bar, we would be missing pulses every time that speck of dust or sawdust blocked the light that passes through the code wheel. So let's click yes on missing pulses. It says click OK to start test or cancel to exit test. So we'll click OK. And when it sees the first home pulse, the counters will be reset. And we know this is a 500 pulse encoder, so when 500 pulses have been reached, the test will stop. And it'll tell us if we're missing any pulses. Oh, there goes an ambulance. Somebody's having a bad day. Okay, we've reached our first home pulse. The counters have reset. On this encoder, when that reaches 500, the stepper motor will stop. There we are. Encoder pulse count equals 500. Click OK. Encoder passed the missing pulse test. That means that A was equal to A bar, B was equal to B bar, and A and B and A bar and B bar were equal. No missing pulses. Nice. Now, one other function that I use quite a bit, and this is when I'm adjusting encoders. Some of your incremental encoders have potentiometers on the back so that you can adjust the duty cycle. You can click this, and we have, let me reset those counters. We have a duty cycle of 44.3 and 46.2, thereabouts. Now, I've got it dialed in pretty close. A good encoder would be 49.5, 49.5 to 50.5 duty cycle. Now, what I mean by duty cycle is that when the high side and the low side are equal, we have a 50% duty cycle. Now, if the high side is narrower than the lower side, then the duty cycle is less. Or if the high side is greater in width than the low side, the duty cycle is more than 50%. But here, the average high side is less than the low side. Now, if we are within, let me move the arrow out of the way, if we are within this tolerance of 49.5 and 50.5, then this would say good, and they'd be lit up as green. Okay. Set that triggering again. Let's reset it home again. Just saw a home pulse. The A and B counters have reset to 0 and counting up again. Now, as looking into the shaft of the encoder, it is moving counterclockwise as viewing into the shaft of this encoder. And you'll see that B is leading A. We can change direction with this button down here. And let's see what our waveform looks like. Now you can see that the leading edge of A is ahead of the leading edge of B. And as looking into the shaft of the encoder, it is rotating clockwise. There's a couple of things that I rarely use, and that is the speed of the stepper motor and the X magnification, and also the save to disk function. I rarely ever use that, but let me show you how they work. If I click on this radio button, we can narrow the waveform. You see how the pulses A, B, A bar and B bar have narrowed. Also the Z pulse. Let's increase the X magnification. And now they're at their widest point. Over here, I can make the stepper motor run slower or faster. Let's click on the faster button. Running at max speed right there. The problem with running it slower is that at some point the stepper motor starts to chatter. Let me show you what I mean. And it'll show up on that encoder waveform there. You see the chatter? Can you see that? Let me trigger. Yeah, we're still triggering. But you can see the chatter because the cogging effect of the stepper motor. So I like to run it a little bit faster. I set it to 110. That's the binary speed of the stepper motor I see on that board. Now let's stop the test, and I'll show you that we can record that waveform. Up here we have the save to disk function. We have record and play, record, stop, and play. Let's click on record, and what we do, let's go to my computer, C disk, the encoder folder, and we will name this test number 1. Click on save. It says click OK to capture or cancel to exit test. So we'll click OK. Now these waveforms are being saved to a disk file under the test 1 name. So let's go ahead and stop. Now click play and we can review what we just saved. Click clear. Okay, we'll pull up the file, encoder test 1, and there, that is what we just saved. It will play out to the end of the file. We'll get a text message when we reach the end of the saved file. There it is. End of disk file. Okay. Oh, one more thing. Let's go to play again. After recording and after playing, let's go again. Open. Let's stop. If you wanted to see the open text file again, you click on clear. But you can click on play again and it will continue with the file that we're looking at. So let's do that. I clicked on play again. We're looking at the same file. Let's click stop. And now to bring up the the play function again to where you want to open up a different file, you have to click clear. Okay? There's a true or false text. No, what am I trying to say? There's a record. No, that's not it either. Okay, brain, come on. There's a bit that is set in my program so that when it is set to 1 or true, you can continue to play. Because the open file is bypassed. Here, let me click on clear and click play. This right here, open text file or open the encoder file, will not come up until you set that bit to false. Did that make any sense? So I'll show you what I mean. Okay, there we are, we're running. We stopped, we play again, and you notice that open dialog box did not pop up. Click stop and click clear, and now when you hit play again, the open dialog box opens up. The reason I had to do that, because if I wanted to continue to look at the open text file or the open encoder file and hit play again, it would open up the open dialog box again when I hit play. That was aggravating. I don't want to load it again. It's already open. So here we stop, play, stop, play. So sometimes you want to look at something as it's going by, but you want to continue going. You don't want to open it up again. It's already open. So here we are at the end of the disk file. I got a little long-winded with that one. Let that run a little bit. Next, we're going to hook up my Encoder Hall Effect Simulator to the encoder tester, and you'll see what it looks like. There's a few things on that board that I need you to know about. That way you can continue using this equipment if need be. This right here is my homemade, invented Encoder Hall Effect Simulator. This is the interface so that we can program the outputs depending on what our servo motor requires. I'll show you the selections that can be made. I've got a chart. Over here is a jumper. I don't know if you can all see that, but if I remove that jumper, this circuit is disabled. So when you go to hook this up and these LEDs just continue to flash and you can't do anything else, install that jumper. That'll make that work. The reason I put that on there is sometimes I leave my equipment laying around. For instance, I passworded the program for the incremental absolute encoder tester. Without that password, you can't get in there. Same with this right here. If that jumper is removed, this right here is useless. It will not work. I'll show you that here in a second. But there's a power supply underneath the interface board, and you apply 8 to 10 volts on this connector right here, G being ground, V being the voltage input. Yellow wires where we apply 8 volts and down, and that will power up the circuit. these LEDs down here indicate how the device is programmed. And then these red LEDs, that's the green LEDs. So if it's if we have encoder out, Hall effect out on the differential side, or encoder out, Hall effect on the open collector side. So this bottom LED would be encoder out on the differential side, differential output. The second one up is Hall effect output on the differential side. Then we have encoder output on the open collector side, the third LED up. The fourth green LED would indicate that we have output on the open collector Hall effect side. So P6 right here is the differential outputs, and P5 is the open collector outputs. So we need to power this up. See if it comes on. Okay, we're on. Now, just disconnect the encoder that we've been just looking at. And we're going to connect the encoder simulator to, get on there, the encoder tester. Okay, I'm going to put this up at the end of the video, but this is how to program my invention. Well, we have a fast blinking LED on the button, button 1, button 2, and a slow blinking LED on buttons 1 and 2. This is button number 1 and number 2. And then the buttons are labeled A, B, C, D, and E. The asterisks over here indicate the default setting. So when it powers up and I just push button number 1 without pushing a subsequent A, B, C, D, E, then the pulses per revolution is 1,000. And if I push button number 2, then the output type for the incremental encoder in Hall effect is differential output using the part number AM26LS31. And at this point, the LED on the button would be blinking slowly. And if I push button number 1, then the leading edge of the Z pulse, the Z pulse will trigger on the leading edge of B. And the width of the Z pulse, we're blinking slowly on number 2 now. The default is a wide Z pulse. Press number 2. Now if you want to select up a different, let's say we want to do 50 pulses per revolution, I would push and hold the A button and then press the number 1 button while I'm holding the A button, and that will set up the encoder to 50 pulses per revolution. Put this up at the end of the video. Let's power up. Okay, we're going to go to the defaults. Pressing button number 1, 1,000 pulses per revolution. Differential outputs. Z pulse triggers on the leading edge of the B pulse. and we have wide Z-pulse. Now, let's go select up 5 volts for the encoder. Start the test. Let me turn the motor power off. Slow everybody down. There we go. That looks good. We'll click reset at home. We'll trigger on the A channel. There's a speed pot right here. There's also 2 switches right here. I got them jumped together. So if I pull this switch, that stops the output. Put the switch back in. Now this is direction. If I pull that switch, the encoder runs in the opposite direction. Let's put that back in. The speed pot's coming undone. Gotta get me a new speed pot. We're overshooting. Yeah. Let me see if I can fix that real quick. The screws on my speed pot connector came undone. It was wigging out the program in that PIC 16F877, the analog input. Now let's go down here with my encoder tester and we'll look at the tuning width. Let's click on. You see it says bad, but eventually they'll go green. There, the top one has gone green, good. Now they're both within tolerance. Now if you could get on the pots of the back side of your encoder, you could tweak, while you're looking at this screen, you could tweak those pots to get as close to 50% duty cycle as you could. You see it says good, good. We're within the 49.5 to 50.5 duty cycle range. Okay, let's exit out of that. Now, since I'm not using an actual encoder turned by that stepper motor, I've turned the motor power off. That's the purpose of that switch, so that we're not wasting energy on something that's not being used. We can disconnect that stepper motor from its power source. Let's go over to the encoder simulator and we'll show you the action of the LEDs. Okay, I'm going to remove the security jumper and then apply 8 volts to the power supply input, and you'll see what happens to the LEDs. See that? They alternate back and forth. None of the buttons respond. That's because in the program inside the microcontroller, it goes to look at this jumper. If it's not jumped, then there's an endless loop that it's stuck in, and it will never come out of that endless loop. So we'll power down and we'll reinstall that jumper and power up again. Look at this. We have the fast blink on button number 1. Now if I just press button number 1, it defaults to 1000 pulses per revolution. If I wanted to set it to 50 or 500 or 2500 or 5000 pulses per revolution, I would press these buttons right here. So let's set it to 50. Push button number A and then push button number 1. Now the pulses per revolution is set to 50. If I press button number 2, then default on the outputs is differential, and that's on the incremental encoder output and the Hall effect output. If for instance I wanted to set the output to say open collector, I would press the B button. See, look at our LEDs, they're off right now because it's not programmed. But I press the B button and then press button number 2. And you can see that LED 2 and LED 4 are on, indicating that the Hall effects are open collector and on the encoder side and the Hall effect side. They're both open collector. Now we have a slow blink on button number 1, and we can set the default by just pressing button number 1 to the leading edge of the B pulses where the Z pulse would trigger. But let's say we wanted the leading edge of the A pulse. We hold the B button and then press button number 1. Now when the Z pulse occurs, it will happen on the leading edge of the A pulse. And we can see that button number 2 is blinking. This is the width of the Z pulse. We can have a very wide width or a very narrow width. Let's say we wanted to set it to a very narrow width. I would hold the A button and then press button number 2. And now we're programmed. And when we want to run, we shall close the start switch. This LED right here indicates that we're running clockwise, or counterclockwise, I'm sorry, so that the B pulse would be leading, the leading edge of the B pulse would be leading the leading edge of the A pulse. B leads A. That was hard to say. And if I open the direction switch, now we're counterclockwise, or clockwise, where the A pulse leads the B pulse. So B pulse leads A leads B. We're running, now we're stopped. We're started, A leads B, B leads A. There you go. That's how you program the incremental Hall effect encoder simulator. There's the motor power LED. That needs to be on for that stepper motor to run.